Hi, my name is Nasser. In this video, we will discuss concepts related to probability theory. We will discuss random experiments, sample space, sample points, and events. We will learn these concepts in detail with the help of examples. We will also discuss what is meant by mutually exclusive events. Please hit the subscribe button if you haven't already subscribed. Let's get started. If you toss a coin, you do not know which side of the coin will show up. Likewise, you are uncertain about the outcome of a six-sided dice. The outcome will be either head or tail in the case of tossing a coin, and a number from 1 to 6 in the case of throwing a dice. But before performing the experiment, you are uncertain about the result of the experiment. Tossing of a coin and throwing a dice are two simple examples of a random experiment. So the experiments which have these three properties are called random experiments. First, the experiment can be repeated any number of times under the same conditions. Second, the experiment has two or more possible outcomes. And the third property is that the outcome of the experiment is unpredictable. The set of all possible outcomes of a random experiment is called the sample space of the random experiment. If you throw a coin, head and tail are the possible outcomes. Either head or tail will show up. So the sample space of tossing a coin is the set containing head and tail. We denote them by the letters H and T. A sample space is usually denoted by the capital letter S. The sample space of throwing a six-sided dice contains the elements 1, 2, 3, 4, 5, and 6. Each element of the sample space is called a sample point. Let's talk about events. Any subset of a sample space is called an event. The sample space of throwing a coin consists of a head and tail, so all possible subsets of the sample space are empty set, head, tail, head and tail both. If you have studied set theory, you would know that if a set has n elements, the number of all subsets of that set is equal to 2 raised to the power n. Therefore, there can be 2 raised to the power n possible events that can happen if a random experiment has n possible outcomes. Now you may ask the question, why are there 2 raised to the power n events if the possible outcomes are only n? After all, the experiment will result in only one of the possible outcomes. So there should be n events if there are n possible outcomes. Another question is, why an empty set is an event? These are relevant questions. You will get all the answers later in this video when we discuss practical scenarios. At this point, just keep in mind that any subset of the sample space is an event, be it an empty set or the sample space itself. Let's talk about mutually exclusive events. Two events are called mutually exclusive if their intersection is an empty set. We have the sample space of throwing a six-sided dice. E1, E2 and E3 are three different events. The events E1 and E2 have no common element, so their intersection is an empty set. The events E2 and E3 also don't have any common element. Their intersection is also an empty set. However, the events E1 and E3 have two common elements. Their intersection is not an empty set. The events E1 and E2 are mutually exclusive events. E2 and E3 are also mutually exclusive events. On the other hand, the events E1 and E3 are not mutually exclusive. Mutually exclusive events are the events that cannot happen together. What does it mean by events happening together? Are there events that can happen together? Is it possible that a dice shows up 5 as well as 6 at the same time? In this case, the answer is no. The dice will either show a 5 or a 6 or any other number from 1 to 6. But there can be many other events that can happen together during the same trial of a random experiment. You will understand these concepts in detail as we go down the road. Let's find out the sample space of throwing two coins at the same time. We consider throwing 2 coins as one random experiment. What are all possible outcomes? The first possibility is that both coins show up the head. The second possibility is that the first coin shows a head and the second coin shows the tail. The third possible outcome is a tail and a head. The first coin shows the tail and the second coin shows the head. And the fourth and the last possible outcome is both coins resulting in a tail. These are all the possible outcomes that can happen when you toss 2 coins at the same time. Therefore, the sample space of throwing 2 coins consists of the elements head, 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 tail, tail, head, and tail, tail. Head, head is one sample point, head, tail is another sample point, and likewise tail, head is a sample point, and tail, tail is another sample point. Now let's consider the random experiment of throwing 2 dice at the same time. This is the sample space of throwing 2 6-sided dice at the same time. An ordered pair 2, 3 means that the first dice shows the number 2 and the second dice shows the number 3. The sample space contains 36 sample points. Please remember that these are not all possible events. These are the sample points. The number of events is equal to 2 raised to the power 36. Let's discuss practical scenarios to understand the events in detail. There are 2 people, Alice and Bob. Alice and Bob play a game of throwing a 6-sided dice. They play this game 4 times, each time with a different winning criterion. So there are 4 different scenarios that we will discuss. In the first scenario, Alice will win if the dice shows up an even number and Bob will win if the dice shows up an odd number. So the event that Alice will win contains the numbers 2, 4 and 6, and the event that Bob will win contains the numbers 1, 3 and 5. Now you notice how an event can contain more than one sample point. Showing up an even number is one event and showing up an odd number is another event. Another thing you should notice is that event even will be said to occur if either 2 or 4 or 6 shows up. 2, 4 or 6 will not be showing up at the same time, but if any one of the sample points of the event occurs, then we say that the event has occurred. Notice that the events even and E2 have no common element. Now consider another winning criterion. In this scenario, Alice will win if 1, 2 or 4 show up. The event that Alice will win contains the numbers 1, 2 and 4. Bob will win if 3, 5 or 6 show up. Therefore, the event that Bob will win contains the numbers 3, 5 and 6. Again, in the second scenario, the 2 events have no common element. We have the third scenario with a different winning criterion. In this scenario, Alice will win if 2, 3 or 5 will show up and Bob will win if 1, 5 or 6 will show up. The event that Alice will win contains 2, 3 and 5 and the event that Bob will win contains the numbers 1, 5 and 6. In the third scenario, the 2 events have 5 as a common element. In the fourth and the last scenario, Alice will win if 3 or 6 show up and Bob will win if 1, 3 or 4 show up. In this scenario, the 2 events have 3 as a common element. These are the 4 different scenarios that we will discuss one by one. Let us ask the question, is it possible that both Alice and Bob win at the same time? Let's consider the first scenario. It is not possible in the first scenario because if the dice shows up an even number, then Alice will win and Bob will lose, and vice versa. In the second scenario, it is also not possible that both Alice and Bob win at the same time. If 1, 2 or 4 show up, then Alice will win and Bob will lose, and if 3, 5 or 6 show up, Bob will win and Alice will lose. What about the third scenario? Yes, it is possible that Alice and Bob win at the same time. If the dice shows up the number 5, both Alice and Bob win at the same time. In that case, both events, the winning of Alice and the winning of Bob, happen together. This is also true for the last scenario. Alice and Bob win at the same time if the dice shows up the number 3 in the last scenario. Now you see how two events can happen together. In the third scenario, if the dice shows up the number 5, then both of the events E1 and E2 will occur at the same time. Likewise, in the fourth scenario, the two events will happen together if the dice shows up the number 3. So, in the first two scenarios, the two events are mutually exclusive, whereas in the last two scenarios, the two events are not mutually exclusive. They can happen together. Let us discuss how we can interpret the set notations. A is a subset of the sample space. S means that A is an event. A is an empty set means that A is an impossible event. A is equal to the sample space. S means the sure event, the event that always happens. The set union of two events A and B is interpreted as the occurrence of either the event A or the event B. The intersection of events A and B means that events A and B occur at the same time. You have already seen this in the game between Alice and Bob. Both Alice and Bob won if the intersection of the two events E1 and E2 occurred. The complement of event A means that event A does not happen. Let us consider the sample space of throwing a dice and an event A consisting of the numbers 1, 2 and 3. The event A complement contains the elements 3, 4 and 6. So if A complement happens, then A does not happen, and vice versa. And finally, if the intersection of the two events A and B is an empty set, it means that A and B are mutually exclusive events. They cannot happen together. So this was a short video about the basic concepts of probability theory. I'll upload more videos about probability theory in the coming days. I hope you enjoyed this video. If you did, please click the like button and write your feedback in the comments section. Please subscribe the channel if you haven't already subscribed. Thanks for watching.